to confusion and erroneous drawings when not done correctly. The steps outlined above help to ensure that you draw an oxygen. And oxygen brings 6 electrons, and there are 2 of them. Therefore, I need a total of 16 electrons accounted for at the end of my diagram. I'm going to start by drawing a simple structure with carbon in the center and the oxygen surrounding it. By doing that, I've used up 4 electrons in these single bonds, 2 in this bond and 2 in this. So I'm going to subtract the 4 electrons. I now have to account for 12 additional electrons. I'm going to place those 12 electrons first around the outer atoms, filling up their valence shell. Since oxygen already has 2 electrons accounted for from this bond, that means there are 6 more electrons that I can place around the oxygen. And similarly on this oxygen, I can do the same. I've now accounted for all of my valence electrons. In order to determine if my structure is correct, what I now need to do is calculate the formal charge. The formal charge is the charge that exists on the atom as a result of the electron arrangement from the bonds. The formula for calculating a formal charge is equal to the number of valence electrons minus the number of bonds minus the number of lone electrons. If I look at this structure, let's start with the oxygen. The oxygen had 6 valence electrons. Take away 1 for the bond, and I'm at 5. Take away 1 for each lone electron, 4, 3, 2, 1, 0, -1. Similarly, this oxygen had 6 valence electrons. Take away 1 for the bond, 5, 4, 3, 2, 1, 0, -1. If I look at the carbon had 4 valence electrons. Take away 1 for each bond, and I'm at +2. You'll notice, because this is a neutral compound, all of my formal charges add up to 0 in this case. But atoms want to be arranged and have bonds so that their formal charges are minimized, so that they have the lowest possible formal charge available to them. In order to do this, I'm going to rearrange some electrons. I'm going to take the lone electrons from the oxygen and move it over to the carbon. If I now recalculate the formal charge on that oxygen had 6 valence electrons. Take away 1 for each bond, so 5, 4, 3, 2, 1, 0. That oxygen now has a formal charge of 0. If I look at carbon, it had 4 valence electrons. Take away 1 for each bond, and I'm down to +1. Since I haven't done anything with this oxygen, it'll still be at -1. To minimize the formal charge on that oxygen, I'm going to do the same thing. Take a lone pair of electrons, make them into a single bond. So now, if I calculate the formal charge on the oxygen, it had 6 valence electrons, 5, 4, 3, 2, 1, 0. And if I take the carbon, it had 4 valence electrons, take away 1 for each bond, 3, 2, 1, 0. Since all atoms now have a minimized formal charge, and in this case a formal charge of 0, I know that my structure is correct. Let's look at another example.